So the next step of the collision avoidance after data collection is to train our model. And for this step, we connected our JetBot directly to the power supply instead of the power bank because it may not be able to handle the GPU processing and training of our data. First of all, we need to import the required libraries where we are going to use the torch and torch vision. So we are importing those libraries, and we have a compressed version of our dataset. We need to uncompress it, but in our cases, we already have the uncompressed folder, so we don't need to run this function. And then we create a dataset where we define our normalization, we resize our image, and then we'll divide our dataset into a training and testing dataset. So the training dataset, it will be all image minus 50 images, and those 50 images, it will be for testing purpose. And you will see like there is a 289 image for the training, and we create a data loader for each dataset, training and testing dataset. And for our models, we are going to import the AlexNet model, and then we are going to change the last layer of our AlexNet model from 1000 to 2 classes, because AlexNet is already trained into classifying 1000 classes, and our case it only has 2 classes, free and blocked. And later on, we are going to transfer our model to the GPU. And here is the training process where we are going to run like 15 echo initially, and we'll see. And we'll monitor the test accuracy each echo, which is starting with 90%, and it's oscillating like 90, 80, 90, and we'll see after 10 echo how the test accuracy is changing. Here we are just see the echo and the test accuracy based on this code, and we could do the same if we train the model with the plot. So we could create a plot of the accuracy and the loss. So let's try that one. So we'll do the same here. Here you'll find only we are importing a bouquet bucket, which is used for the graphical interface for the graphs. Here it is for 15 epoch, and we'll see 2 graphs, one for the loss, one for the accuracy. Each one, it will show us the train data set and test data set. You'll see that the accuracy for both of them, it's increasing with the time, and we'll see that the loss is supposed to go down with the time. As you see here, and at the end it will generate for us the best model. And same we can do it for the ResNet. Initially we use the AlexNet, we can train our model with the ResNet. So we are doing almost all the same step, we just changing the model. Here we just put it for 30 epoch, and we'll see how the model is trained after the 30 epoch. After waiting a couple of seconds, and we can see that 30 epochs is generated for us accuracy of 94-92% on the last 2 epochs, and it saved it as best model ResNet18. And now we can use this model and convert it into TensorRT. And first of all, we need to import the libraries, the torch and torch version, and collect the ResNet model, load our model, and transfer it into the GPU. Then we'll use a torch to TRT to convert our model into TensorRT and save the model. And after a couple of seconds, waiting for a couple of seconds, we can find that we already have our base model underscore TRT is saved for us, which will be used later on for the live demo.